evaluating functions. So now the idea is whenever we're evaluating functions, basically there are two things that we're focusing. One, we're focusing on finding input, or we might be finding outputs. We want to understand this, that whenever we have a coordinate is a combination of an input that actually produces an output. Generally speaking, our input is normally on the coordinate plane, an x value, and our output is the y value. So depending on the situation that we have, we're going to get inputs to find outputs and get outputs to find inputs. For example, in this case here, right? In this case here, we're asked to find 3. We're asked to find r of 3, which means that we're going to take the r function. For example, our function says r of x is equal to 5x minus 3.5. We're going to take this r function, and we're going to substitute 3 where x is. For example, 5 times 3, and then we're going to take 3.5. 5 times 3 will give us 15 minus 3.5, and that is 11.5. The idea is that this 3 took the place of x, and we carry out the mathematical operation that was taking place there in an effort to get the answer. Let's move forward. We're going to do r of 6.5. Well, it depends on how you want to see this. 6.5 is the same thing as r of 6.5, right? So the r function is as follows. It says r of x is equal to 5x minus 3.5. What we're going to do here is we're going to find r of 6.5, which is 6.5. So 5 times 6.5 minus 3.5. If I multiply 5 times 6.5, I'll get 32.5. And then I'm going to take 3.5 from this, and my final response would be 29. Again, I was given the input 6.5, which means that I'm in search of the output, but this input was inserted for x, and then we carry out the mathematical operations and then finalize the answer. Let us see what we're dealing with now for question 3. For question 3, it actually says here, for a value of x is r of x equal to, basically, this is an output value. We're in search of x. So let us start off by writing the r function. R of x is equal to 5x minus 3.5. Remember, we're told that r of x is equal to 21, which means I could put r of x 21. I could put negative 21 for r of x, for example, right here. Negative 21. I'm putting that in place of r of x right here. See that? So we continue. Negative 21 is equal to 5x minus 3.5. So I'm in search of the input x. So what we're going to do is regular solving of this equation by adding 3.5 to both sides. And when we add 3.5 to both sides right now, on the left side, I'm going to be left with negative 17.5. And this is equal to 5x. We're going to divide both sides by 5x. And then I'm left with negative 3.5. This is equal to x. Or you could turn it around and say x is equal to negative 3.5. So we have just found the input value that would have gone in the function to produce negative 21. All right, let's take a look. Now we're going to be evaluating a graph, right? So this question says, use the graph of y equal to f of x to find each value. All right, so we're looking at the graph here, right? So here's our graph on this side. So let's take a quick look on what's actually is going on, right? So then the first question is saying, we want to find the value of 5 or f of negative 4. Now, if we're not sure, we could put on some labels on this graph. For example, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. What we want to find is f of negative 4. So I'm going to go on the x-axis right here because this is an input value, right? So it's on the x-axis. So if you want me to label, this is our x and this is our y. So I'm on the x-axis, and on the x-axis, what I want to do is to find that negative 4. I've highlighted it in yellow, and I'm going to look at the line that passes through negative 4. And the moment it touches the curve, I would stop. At this time, what I want to do is to read off the value here. This is negative 1, then negative 2, negative 3, negative 4, and it goes on. So at this moment, we're seeing that negative 4 would have linked to negative 1. So f of negative 4 is negative 1. Let's look at the second part here, number 5. What we want to do here is to find f of 1. So I'm going to go where positive 1 is, right? So this is the line that passed through positive 1. I'm going to carry it until it touches the curve. Whenever it touches the curve, I'm going to stop. Then I'm going to read off the value on the y-axis, and that is negative 2, which means that f of 1 is negative 2. Let's go to number 6. Number 6 says, for what value, right? It says, for what value of x is f of x negative 4? If you notice this time, we actually got the output. And if we got the output, we want to know what input would have produced that. So in other words, then, we're going to start on the y-axis because we got the output, right? So this is the line that passes through negative 4 as an output. And I'm going to take it to the curve. It touches the curve right here. The moment it touched the curve, I'm going to take it to the x-axis to see what number is here. And you could see that's negative, that's positive 4. So what we're suggesting that this is positive 4. The value of x that would have produced negative 4 is positive 4. All right, let's keep going. For this one, we're actually using the table, right? So it says, guess what? We want to use the table of values to representing m of x to find each of the values. So firstly, we want to find m of negative 4. Take a quick look. These are our inputs, always the x values, and our outputs, right? It's m of x, or it could be called y. In this context, it's m of x. So this is an input value. So we're going to look in the table under the inputs. Here is negative 4. And we're going to see what output it had produced, negative 9. So right there, quite easily, we could pick up those values right there. Let's go further. We want to look at m of 4. This is 4. Let's look at the value that it actually picks up, negative 5. So m of 4 produces negative 5. Let's look on number 9. What is the y-intercept of the function in the table? That is information that we need to know. Whenever we're looking for the y-intercept, we need to look where x is 0. And if we're looking for the x-intercept, we look where y is 0. But this question simply asks for the y-intercept. So I'll make a note. Wherever we have the y-intercept, right? For y-intercept, x is equal to 0, right? And this is for y-intercept. So that means, right? Let me write this better. Need to spend some time to write better, right? So x is 0 whenever we're dealing with the y-intercept, right? So in this context, I'm going to look for an input value for x, right? So the input value for x as 0 would have produced 8, right? So in this case, our y-intercept would have been at the coordinate 0, 8. This is x and this is the y, and this is what we're suggesting. So here is the response. What is the y-intercept of the function table, right? So the y-intercept is at 0 means 8. That's the coordinate for the y-intercept. Number 10, and final, it says, given, it says, given d of x is equal to 3x cubed minus 4x squared plus 2, evaluate d of x for x equal -1. Well, this is the same idea. This is the input. And this is another way of asking you to evaluate d of -1. So this is the same context in another way. So this is another way they could have written it. They could have said x is equal to -1. So they're suggesting that if you look, all you have to do is to substitute the values for x there, which is -1, and then see what we get. So let us go, right? So basically, this is going to equal to 3 times -1 to the third minus 4 times -1 square plus 2. -1 to the third is -1 times 3, -3. -1 square is 1 times -4, -4 plus 2. We're looking at -7 plus 2. And finally, this becomes -5. And that's our final response. There we go. We were evaluating functions. I trust that this makes sense to you. See you next time.